Alright, so this problem, we have 25 women, 22 men, and we know exactly 12 of them are going to show up to the reunion. So there's going to be a group of 12. And we got to find the probability that there's 6 men and 6 women in that group of 12. So I'm actually going to change the numbers a little bit so you can see exactly how to work through it, but with some different numbers, so then you can go back through and figure this one out. The key to setting this up is to know the basic ratio for probability, where if you're trying to find the probability of a specific outcome, this basic fundamental ratio says on the bottom of the ratio you should have the total number of possible outcomes, and in the top part of the ratio should be the number of ways to get this specific outcome. Alright, so like I said, I was changing the numbers a little bit, and the problem I'm going to work out, there are 20 women and 18 men, and we're going to have 10 of them, a group of 10, show up at the high school reunion. Okay? And what's the probability that we have 4 women and 6 men? So that would be 10 total people. 4 women, 6 men would make up our group of 10. What's the chances that we get this breakdown? Well, we're just going to use this ratio here. If we can set that up, we'll have the probability. So let's start with the bottom, the total number of possible outcomes. The key thing to realize is how many total people you have to choose from. If we have 20 women and 18 men, that is 38 total people. All right. So what we're asking is how many possible outcomes, how many possible groups of size 10 can you make out of 38 people? And that's what combinations tell us. If we had 38 people and we made a combination of size 10, so this number gives us the total number of groups of size 10 if we had 38 people to pick from for that group of size 10. Now what do we got to do on top? Well, before we do that, I want to just quickly rehash the fundamental counting principle. I think you probably seen the example. If you had 3 shirts, let's say you had 2 pairs of pants and 4 hats, how many different outfits can you make? So how many outfits can you make? Well, to get the total number of possibilities, you just say I had 3 possibilities for that first option, and you multiply it by the number of possibilities you have for that second option. And here we have a third option, so multiply by that again. So what do we get here? 24. So we're going to use that on the top. That's why I wanted to go back and do an example. You have 24 possible outfits because you have 3 choices for the first thing, and multiply that by your choices for the second outcome, and multiply that by your choices for the third. So on top, we're going to have how many different ways can we make a group of 4 women, and how many different ways can we make a group of 6 men, and we're going to multiply those together because it goes back to the fundamental counting principle. That'll tell us the total number of possible groups made of 4 women, 6 men. So enough of me talking, let me put the numbers together here. There's 20 women and we want 4 of them in our group. So how many total different options do you have? 20, and you're making a group of 4. This is the number of ways you can select a group of 4 women. And multiply that by the number of ways you can select a group of 6 men. So that would be there's 18 men, and we're choosing 6 of them. So 4 women, 6 men, that gives us 10 total. But yeah, figure these 2 numbers out, multiply them together, and then divide by that number. And I'm punching it into my calculator. You should get. Alright, so I put these numbers in the calculator. So there's this many ways, 4,845 options to choose a group of 4 women. Multiply that by the number of ways to choose a group of 6 men. That'll give you the total number of ways to get the specific outcome you're looking for, which is 4 women, 6 men, and divide by 38 combination 10, which is that long number, and you get 0.19026. Your calculator should be able to handle all these. If not, there are some nice ones online. Just do a combinations and permutations calculator. There's a bunch to choose from. Is order important? No is combinations. Yes is permutations. But yeah, so to go back to, just to really hit this home, let's say this problem changed and instead of 4 women, 6 men, let's say it was, just going to make something up, let's go with 3 women. Well, that would mean we had 7 men then to make a group of 10. So the only thing that's going to change here then is on top, out of the 20 women, we are choosing 3 this time. How many ways can we do that? Then out of the 18 men, we're choosing 7 this time. And again, multiply those two together, and you'll get something different than all this, but whatever these numbers are, it's going to change the number of people you select for your group of women, the number you select for your group of men. So go back to your original problem. You're going to have different groups of women, or sorry, a different number of women and a different number of men. 25 and 22. So it's going to be 25 women, 22 men. And make sure you get the correct total down here for the total number of people. Here's the second problem I saw you send a question about. So you said you know how to do the first part, where, let me clear this all out, sorry. 6 out of 53 numbers, so just to set that up, make sure we're on the same page here. There's 63 and you're going to choose a combination of 6 of them. Alright, so that's the number of different ways you could pick the ticket. So if you only buy 1 ticket, you have a 1 out of whatever that number comes out to. 63 choosing 6, or was it 53 number? Oh, only 53 numbers. I've been typing that in wrong. Sorry, 53, not 63 numbers. Sorry about that. So this is your probability if you just buy 1 ticket, and that's what part A was asking. You have a 1 chance out of all of that. Part B says you're buying 100 tickets. So instead of just having 1 option to make you correct, how many ways can you get a winning ticket? Now you have 100. So you're going to multiply that previous probability by 100. And so for part B, you just have 100 on top instead of just 1 chance of winning.